All right. Looks like we're live. All right. Hello. Hello. Welcome to the Swift stream. I'm Zach, and I'm joined with me by Sarah. We're gonna go through and talk about these fun little topics that I have up here. If you're in the chat, YouTube chat or Discord chat, feel free to ask questions. If you have any, I would love to go through any examples. But pretty much we're just going to talk about these three topics, structs and protocols, going through a little bit more examples, when to use them, other things like that, codable, and showing an example of a protocol and what it can do for us. And then just getting some data from the internet, making a call to somewhere and getting that data and then using it in the code. All right. Just checking. All right, do you have everything set up, Sarah? All right, cool. Can you, well, really quick, I'll just show, if you're going to create a project and follow along, you can either create a playground or a new project. And what I did is just go to macOS, command line tool, and then you can just name it whatever as long as it's Swift. And you'll have exactly what I have. Okay. So with protocols and structs, they're used a lot in Swift. Swift is a protocol-oriented programming language that's different than object-oriented. Swift can still do object-oriented. It can still inherit from a class. A class can inherit from a class, so it can still achieve that. But it mainly tries to focus on structs and protocols. So an example of a struct is, oh, that's huge. Struct. Let's say, one sec, I had an example. I'm trying to remember now. Okay, so let's say we have players. Okay, and for a player, we want the player to have a name. So that name is a string. Okay, let's think what else. How about a level? Okay. And let's add a few more things like a class. Oops. So Swift has a keyword of class. So we can still name it class, but you have to do backticks. But let's not do that. Let's do game class and just call it a string for whatever class they play or anything. And then let's just have the items in their inventory. Okay. All right, so we have that. And so now, what can we do with this? Well, let's create a player, and let's create, well, I don't really want to, I guess player one. I don't really care for the name of the variable, but let's create a player and give it all of the values that it needs. So let's do Bill's level is 3. Game class. Oh, and I missed the equals, so that's why it's not typing for me. And he has no items. Okay. So now we have a player with this kind of data. So just really basic example of a struct. All right, so that's easy enough. Let's add a protocol though that we can do something with. Do you have this yet, Sarah? I know you're typing with me, so. Okay, cool. Let's do a protocol called printable, and we'll just have a function called prettyprint. Okay. So this ideally will just let anything that is printable or extends from printable, we'll have prettyprint, and it can call that. So for our struct, or player, we want to do an extension on it. We can either do an extension, or we can just put printable right up here, and it achieves the same effect. We only need one of them though, so I prefer the extensions, and I try to put all the logic of what printable or whatever thing we're extending brings into the code. Otherwise, it gets kind of confusing if everything's in struct. So that's why I try to leave it just with the variables, and then the functionality I try to extend out. Okay. So for pretty print, let's just do a simple print of, just print the name in a nice way, and we'll just use that to put the name right there. And then we will, how about, let's put the level in parentheses, just like that. Something simple, not too much. We don't have to put everything in there. But now our player extends from printable, so we should be able to player one pretty print. And there we go. Now I'm going to zoom this out a little to kind of get a little bit more of the code. So now we can do that, okay? So we're kind of back to where we were before, where we were showing this example of we've gotten functionality because we have printable. So now we can call pretty print. Okay. Do you have that, Sarah? Okay, cool. And so you should be able to run that, and it should print out Bill level 3. Oh, I missed the, there we go. There we go. So now it prints out Bill and level 3. Okay. All right, awesome. So going into the examples a little bit more. Hold on a sec. I'm just making sure the chat's fine. Looks like my stream chat's not working. Okay, awesome. So what's codable? Well, before we go on to there, do we have any questions on structs or protocols, or an example of a struct or a protocol? Mm-hmm. So the question was, if you're not in the Discord chat, or the Discord voice chat, the question was, is structs the same as, would you say a class or a function, or? Okay, yeah, so Java only has classes, and it doesn't let you make a struct. So yeah, a class is the closest thing that you can understand what a struct is. But structs are a lot different because they're not reference types. Okay, so value type. All right. So we have a value type of player. All right. Does that make sense? Do you want me to touch on a little bit more on value versus reference, Sarah? So what value type means specifically, more simplified, is that it doesn't have, it can't have a shared reference. It doesn't, when you pass it to a function and that function modifies it, it doesn't change your value outside of the function. But if you had a class and you did the same thing, it would change your value. Have you seen that example before, or? I'd love to. Okay, so let's go through this, and let's use a protocol to kind of help us. All right. So I'm just trying to experiment a little bit more with protocols, so we'll just find something. Let's go. Trying to think. I'm just trying to think of a variable name. I'm so bad at variable names. Level. We'll just remove the level that they have. Level int and var. There we go. All right, and I think that's good. Yep. Well, I didn't even extend from it. Well, that's my bad. So if we do extension, actually, I'll do the extension up here because it kind of makes more sense since we have a variable. So you have to declare all variables in here if you want them to act like a normal variable. Otherwise, the extension won't really work that well. So, right, everything works good. It's because we have level. We have var int right here, or var level int, and then var level int right there. So, boom, that's why that's fine. So let's create another thing, but let's do a reference type. So we have a class enemy, and let's say enemy is levelable. So then it has a var level int. Okay, and let's just default this to 0. Just because the fact that classes need here, I'll just show you. Classes need a constructor and initializer if you don't set a default value. Structs, on the other hand, are really nice. They'll automatically build the constructors for you. So that's why I was able to do this. But when I create an enemy, oops, can't type, enemy, then I just get a default constructor and I have to modify it. Enemy. Okay. All right. So let's get something out of the way really quick. Let's do the exact same thing. I'm modifying enemy's level up there. Let's modify player 1's level down here. And already we see a difference. Now, let means it's a constant, so the value will not change from this variable, okay? So let player 1 means that player 1's value should always be the same, and the same thing for enemy. Now the reason I can modify enemy is because it's a class and not a struct. So talking a little bit more about structs is anytime you change a value on a struct, it changes the whole object. So that's why it needs to be a var to actually change that. So that's one difference. But let's make a function, just a simple, whoops, after this, do stuff. Actually, instead of creating a function, I'm still going to create a function, but let's do an extension on levelable. And now let's create a function on levelable do stuff. There we go. Okay. So now let's change level to, let's add 10 to it. Let's add 10 to any level when we do stuff. Alright, so now it says left side is mutating operator isn't mutable. So what it tells us to do is it tells us to mark the method as mutating. So the reason it tells us to mark it as mutating is the exact same fact, or the exact same reason as if we would do anything that modifies something here. So if we had something that changed our name in the struct, well, the struct would give us the same error. Oh, well, I mean, it first needs to be a var, so I can change it. But it says to make it mutating. So that's why you'll hear protocols and structs a lot of the time, and that's not the reason, but this is another thing that points at that protocols will to know that a struct needs to mutate it. Okay. So this would allow. Here, let's get rid of this. We'll get the levels the same, and we'll see if they both do the same thing. Okay. Sorry, I was just checking. So enemy dot do. Oh, did I write it below? Oh. Enemies levelable and players levelable. Yeah. Alright, cool. Alright, do stuff, and player 1, do stuff. Okay. Alright, so yeah, it's saying that we can't mutate our value, and that's because we actually need to change this to a var now. And that's because it's actually mutating the value. So if we get rid of this, it still complains and won't let us. So we have to have it as mutating. So that's just something with protocol. And here, so if we run it, and then boom, we added 10 to Bob's level. And if we wanted to really quickly print out enemy.level, well then I would expect it to be 15. Yep. Alright, awesome. Any questions on that? Alright, cool. So that's a lot of that. Let's get rid of this. And let's just go with player. Okay. Alright, so with player, let's this is gonna be dumb. Just move it down. Alright, now we're at codable. Cool. So for codable, let's just, add codable. Okay. So codable is a protocol, or I mean, it's actually a type alias for two different protocols, decodable and encodable. So as I was saying before, codable allows us to decode JSON and convert it or decode it into a player, or encode a player into JSON. So I'll show that later when we do the get example. But really, that's it. Now I can switch it to JSON. So let's again create a player, and we'll see how easy it is to encode it into JSON to send it. Whoops. Name. Okay. And so if we wanted to get this as JSON data, all we need to do is try, and I'm just going to do an optional try, just for simplicity. Actually, let's force it. Just if there's an error, we care about it. JSON encoder, create it, and then encode test player. Okay. All right, that's cool. How do we know that we can actually, or how can we actually know that that data is real or actually a JSON or anything? I use JSON serialization. And we can, where is it? Oh no, where's the value? The thing. Oh, there it is. It's just a static one. So we will just do the JSON object with data and then options. So this throws, so we're gonna have to do a try, but let's do JSON data, and then we will just, can we just take in no options? Or is this no? Oh, it has a default. Okay. So we don't even need this. All right, cool. So let's try. All right. And let's run it. And now, boom. All right, that's the JSON data, all right? I mean, it's not verbatim because it's missing the quotations, but you can see that this is supposed to be an array. So if I start adding items, then these items will be added to my array. So you can see the JSON data right here. Okay. All right. So that's cool. Do you have any questions on that before we try to get some JSON data from the internet, Sarah? So JSON is JavaScript object notation, and it's just kind of the standard for what JavaScript uses, and it's a big standard in general for how to order data kind of consistently throughout objects. And you can see that I wrote a struct, which is just, you know, base level of this, but it can map into it maps into this format. So we can see there's not a player, we ignore that, but we have name, level, items, and game class, okay? And this is a string, this is a number and int, this is a string and strings, okay? But it's used a lot to send data and receive data, but there's also other types of data formats like XML or CSV. Those are other types that are commonly used. I really like JSON. It's really nice, and since codable is just it's just extending from codable, it's pretty easy to use in Swift, at least for JSON. And a lot of the APIs that I use or I hit are JSON, so it's just convenient then. But there's types everywhere, so it depends. Any other questions on that? Okay, cool. All right, so let's get something from the internet. So I have a gist on here, and it's this player's JSON file. So we'll just view the raw one. I'll get this value right here, the URL, and let's remove that. And now we're gonna make a request to, we're gonna make a URL request. So first before we make a URL request, let's just make the URL. So the URL is just a string. It's just this long string, all right? So that's really all it is. The thing though about URL is it returns an optional URL for this initializer because it doesn't know if it's actually a URL. You just gave it some string. So it might not be a URL. So for this case, we'll just force unwrap it. I'd advise using like an iflet or a guardlet, but for this example, we'll just force unwrap it. Okay. So now we're gonna make the request. Oops. And that's just URL request, and it's pretty easy. This is where you can put the headers, the cache information, a lot of information about the request you're sending. But for this, we'll just put in a URL. So we have the URL right there, so now we have this request. So for that, now we want to do a task. We want to get some data with this. So what we want to do is we want to go to URL session. And then dot shared. Yep. So we're going to use the URL session singleton to call from this. So we'll do shared and then dot data task. And we're going to look for the one that says data task with URL and then completion handler. Okay. So I'll hold for this one for a little bit longer to make sure you get it. All right. And oh, of course I picked the wrong one. I mean, yes, you can pick that one. Or you can pick the with URL request. I'm just going to use the URL request because we created one. But regardless, you can still use just the URL. So it really doesn't matter, but I'm going to use the request just because maybe I wanted to send headers or manage cookies or something like that. So then we have the data, the response, and the error. So first off, there's an error, so let's check if that error is actually something guard. And actually, I'll just switch this to an if let. Okay, so I'll just print out the error if it's actually a thing, and let's just return because it's an error. Actually, it doesn't even matter because I'll just have a guard let for the data because the data is optional and the response is optional. So data. So now we have both of those. Oh, yeah. Otherwise, we'll just return. Awesome. So now we can use that. And let's say that we want players. Okay, so we want to get players. And so we'll just do try JSON. We're going to use the decoder now, and we'll just create a decoder. And now we'll just decode player dot self to reference the object player, and then data. All right, that's easy. And we're going to print the response, just to print stuff. And let's print players. All right. Awesome. Okay, so that doesn't do everything we need. Now, to make sure that this data task actually runs, we need to say let task equal this. Make sure you get let task. And then we'll do task dot resume. All right. And so let's try running that. Let's see what happens, and I'll wait for Sarah to catch up. Okay. How you doing, Sarah? No problem. Keep going. Okay, cool. So if you run that, you won't see anything. And that's just simply because we have a command line tool, and once it goes to the very end right here, it just closes our program. Sadly, we're running something in the background, and we're waiting for it. So we're going to use a semaphore, and I'll just throw it at the top right here because I don't really care. And I'll call it sema. And we'll call it dispatch, or it's not called dispatch semaphore, it is a dispatch semaphore. And we give it the initial value of 0. Okay? So if you don't know what a semaphore is, I'll try to give you a quick understanding of it. A semaphore is, you can think of a flag that uses an int, and if it's 0, it's off, and if it's 1 or if it's not 0, it's on, pretty much in this case. So once we say sema.wait, this it's going to block this thread. So we're not going to end. So if I print going to end, and if we print down here, and say we ended, and we run it, okay. Yeah. All right. So, well, that's here one sec. So this broke and didn't really show the point. All right. So let's not do this because that will crash, and that was another point that I was trying to talk about. But right here, we'll see the response, but we don't see ended. Okay. So we should see ended, and that's because it's still running right now. Okay. So the semaphore is 1. It's not 0, so it's blocking the thread, and we can't end. So let's just do sema dot signal. Oops. Yep. So we're gonna signal it, and this means that we're gonna stop blocking this thread. Okay. So that's just going through, because this code is asynchronous, where this, or kind of asynchronous, it's a completion handler. So this code that you write right here is just whatever happens when it's done. Okay. So the resume is specifically to resume it if it's suspended. If you don't do this, it just doesn't run. So now if we run it, since we did a signal in here, now we can end. Okay. So that's just the quick way while you're testing, or right here, that we'll use a semaphore. Normally you won't use a semaphore because you'll be in an app, and the app will keep running, and you can throw this in a background thread and update the main thread whenever. But this is only really one thread, and we're just kind of ending at the end. So now we're doing it right, and let's go back to this error of that. Did that make sense, Sarah, for the semaphore on how we can now wait for the response and then end when we get our response? Yeah, so it is a little confusing. But yeah, pretty much. All right. Well, here. We'll comment this line. So I'm going to run the code with breakpoints, and we'll kind of step through what I mean. So, all right, we're right here. This is the point in code that we're running right now, so I can step and go right here. So we're not going to go down to here, or this line, right now. We're going to wait until we hit in here. So wait, and now we're in here. And that's because we've waited, and now our data task is completing. So we finished our data task, and we would signal to complete the whole thing, but we're going to run through all this code and go at the end, and of course this crashes, but if it didn't crash, then we'd still be waiting. If we signal, we'll go to this line, and then we'll go to ended. It's still a little weird because, yeah, it's like the code's right above it, but it's being ran later. But let's just go with it right now. If anyone has any questions in the chat, feel free to ask. But let's keep going on this because that was just meant to give us that. We don't really have to worry about that too much. But let's see the error that it's giving us. It's saying fatal try, error, key not found, name. All right, it can't find it. And it's saying blah, blah, blah. And that's because the data that we're trying to decode is actually an array, okay? And it's an array of players. So let's just try to make it an array of players and see if that works. I don't know if that'll work because the data has a name, but let's try that. Okay. Well, that didn't work. Doesn't look like we printed players. Let's run that again and see. That's weird. Let's signal at the end. All right, there we go. Oh, missed the bracket, sorry. All right, cool. So it's still going, and now we get something else. Type match an array, and expected to decode an array, but it found a dictionary instead. Okay, cool. So what about if we do that? I mean, I guess it'd technically do this. I'm trying to show the shorthand way, and then I can show, yeah, okay. So that's not what we want. That's too much. So the easier way to do is just to model the data. We can set coding. Maybe we need to set coding keys. Oh yeah. Okay. Okay. Yeah, we need to set coding keys. Okay. Let's do that before we go any further. Sorry. Since we had to change this to game class, not everything matches. So class doesn't match. So we need to make sure that class actually matches for that. So let's do inside of our player codable. We're just going to map the keys manually for us because codable can't really tell, or we're not being literal enough. So we're going to do, can we type it? No. All right. It doesn't fill it out for us. Coding keys and string, and then we'll just do coding keys. All right, cool. All right, coding key, cool. And so this is just an enum where we're going to list out everything that we have for this player. So we'll have case, name, level, and those are just the same, so we can just leave them alone. Items, and we'll just do the last case of player, oh, whoops, game, class, and this equals class in the actual JSON data. Okay. All right, awesome. So now let's run it and see if it works. All right, so yes, it did work. Okay, cool. So that's what I was worried about. I'm like, this should work. Okay, cool. So I'll wait a bit for that to catch up, and then we can go a little bit further into that and kind of mess with this and clean this up. But pretty much what we did is we fetched a URL session, we had a request, and we fetched some data, and we decoded that data into a dictionary, a string to an array of players. So we have a dictionary of string to array of players, and the first string is players. So a way to get around this is to either remove this, just send the empty string, or making an object that will just be an array. So we'll just leave this for this right now because that's simple enough and we're not going to have any more. But maybe the string is the server name. So this is like how many players on this server. Players. I don't know. Do you have any questions, Sarah, on that? I can wait a little bit for you to catch up if you need to. Yeah, that's a good question. A dictionary is pretty much the same thing as a dictionary in real life. Other words that describe a dictionary or other ways that it's called are hash map, hash table, dictionary map, trying to think what else. I swear there's another way, but it's blanking me. But we can create a dictionary, and we'll just give it a string. It's a string dictionary. And pretty much what I can do is you can give it a key, and you can give it a value. So I can put in something cool in the dictionary, and the fact that it's a dictionary means that I look it up by keys. I look it up by, the title or the word itself. So you can think of, the dictionary all the words in the dictionary are all the keys, and all their meanings are the values. So for this dictionary that I created, we're going to go to something, and the value will be cool. Does that make sense? Yeah, kinda. But these are really just like keys and values. That's all it is. It's just a pairing. So it's a pairing of keys and values, okay? So I can't have something twice because it's unique. So if I actually changed something to, something else, well, first it's a constant, so we can't change it, so let's switch it to a var. And now we have that, and if we print out dictionary, we'll print out something else, okay? So we can reference this by the value and change it. But let's say I misspelled it, okay? So let's say I did something, okay? Well, now I have two values in this dictionary, and that's because something is cool, and then this other value is else. So let's not make it a string, let's make it an int, and let's make it I'm trying to think of a clever thing. Float, I don't know. Yeah, float, I guess. Alright, so we can give it a value, and we can give it a float. And we can reference a value, and we can give it some float. Okay? So that's all a dictionary is, or a hash map, table, whatever. In Swift it's called a dictionary. And this one's int to float. So we can reference this value by 4. Okay? Yes. I mean, you can loop over. I can do dictionary.keys, and I can get all the keys. So I can look at all the values, or I can do dictionary.values. But the nice part about a dictionary is if you know the key, or if you use the key like this, then it's instant lookup. You get it, there's no time complexity. It's just, boom, you get it. Always. No matter how big the dictionary or how small the dictionary. So that's the nice part about it. It's like an array. You know the index of the array, so then you can just get the value at instantaneous lookup. So a hash is just a unique value for an item or an object. So the keys have to be hashables. So to explain that, player trying to be our key. Oh, whoops. Player. I think player does not conform to Hashable. So the protocol Hashable defines what can be a key or not. So if you were to extend Hashable on any of your classes or structs, then they could be a key. But that's not really what we want. What we want is more like an enum. Okay. So if we create some enum, okay, and now we can make our dictionary by these hot, cold, warm things. Okay, so that's kind of that's an example of why you'd want to use. Let's do hot, because hot hasn't been defined, and hot is nil, because the dictionary reference is optional. Because you don't know if the value is there or not. Like it says right here, you might type something that's not in there. and that would return nil. Okay, so that's kind of how you'd want to use dictionary. Pass in something that's easy to get the types and or the keys. Okay. All right. Any questions more on that? Cool. So, going back to this, let's see if we can do. Oh, well, here we go. Okay. So all we need to do for here is we'll just create a struct, and we'll just call it world. This is going to be what's containing all of our players. So we'll say let players is just an array of players. Okay. All right. Well, let's switch this now and say world. And now we're going to try to decode world. Okay. Obviously this is wrong now, so we'll say world. Can't type. Ah! And now we can print out the world's players. Okay? And you can see we have 3 players: Leif the Destroyer, Ambid the Necromancer, and Snoozy the Ranger. And they all have their own things. So let's change this really quick. So let's update and let's add Sarah into this. We'll go to edit, and all we have to do is comma, boom. I'll just copy the format because I don't want to do that many tabs. Okay, so Sarah, what do you want to be? Something cool. Cool. And sunglasses. 9001. All right, cool. So we're gonna update this. We'll update that, and now we can run this again. And we don't see anything. Now, why is that? Maybe it didn't update in time. Maybe we got too excited. Maybe the file changed. Whoops. Looks like the file changed. So I'm gonna stitch this. Yep. And so now we do get Sarah the something cool. Alright. I'm gonna make this a little bit smaller. Put this down over here. Kind of encapsulate this. Okay. Alright. So that's how you get data from the internet. That's the kind of old way to do it. There's a newer way that I'm not really going to go over. I'd love to chat about it, or if you want to research it, it's just combine. I can spell it out right here. Combine. But it's more for newer software and that stuff. It only runs on certain software higher than like iOS 13 or the latest Mac OS. So not gonna necessarily use that right now. I do use it, but I would advise at least learning the one that works on, and has worked on every iOS or OS or anything, because this is built into Foundation. So that means that you can do the exact same thing on Linux, but Combine is not ported to Linux yet, so also noting there. But yeah, do you have any questions, Sarah, on anything of that? Do you want to see any examples or anything? I guess anything that leads to an example, or if you any Swift questions? Yeah, I'll try to summarize it. So structs are kind of the default objects that you should use. You should always try to make a struct first. Protocols are really handy in extending functionality. Protocols can have built-in functionality that all you have to do is just extend from them, and they will improve or add functionality to your data object. And we saw that in codable. Codable allows us to decode and encode JSON, and we can turn our object into JSON or turn JSON into our object if it matches up. The other thing is that we can use URL or URL request and URL session to get data from the internet. And we just have to make sure that we understand threads. And right now, I don't mean to fully understand it. I just mean to understand that we did use a semaphore to block our thread until we're done. So there's another topic that I'll touch on later, more when we get to iOS or Grand Central Dispatch, using another queue or another thread to run a data and then updating something. So, but yeah, we just called data task and got the data and response, turned the response into our object, and then we were able to get the data, just referencing it in Swift. So, there's no questions. I don't see why we have to drag it on. There's a lot more topics I'd like to talk in the next stream, but I really wanted to just make this one to get the understanding of making URL request and getting data, but also kind of further elaborating on protocols, codable, and other topics of that. The next topic the next week, I'm thinking about doing more APIs, potentially calling from an API or anything, but I think we will start iOS next week. So we'll see that. And sadly, you'll have to use a Mac. These first three parts I've tried to keep as basic as possible, so you could use Linux, or you could potentially even use Swift Online compiler or online. But yeah, I think next week we'll go into iOS and making more views and making an API call and other things like that, like populating data in the app. Okay. All right, Sarah, any last words before I end it? Yeah, no, thank you for coming. And as a reminder, everyone that watched the video or was just watching, please join the Discord so you can join in our conversation in the voice channels in our Discord. But if you have any questions, feel free to leave a comment or feel free to message me. But yeah, thank you for watching.